All right, guys, this is lesson 6.4, so chapter 6, section 4. We're on the second day of it, so I'm going to kind of skip through these notes, and you should have a note sheet in front of you with the front and back printed on it. So skip through these first notes because we covered this already, the exponential growth. And if you look through these slides here, and they're kind of written on still from 8th hour, but we took care of these slides, and this one I'm not too concerned about. So we're going to come up here and now talk about the second part of chapter 6, section 4, which are differential equations, and the only differential equations we can solve are separable differential equations. So I want to talk through this, and it shouldn't take too long, I think 51 minutes or so, and so it should give you a nice minute or two at the end just to relax, but I think we can get through it somewhat efficiently. Before we do that, though, I know we want a puzzle, and this is for both 3rd hour and 8th hour, and so sometimes in 8th hour I have a student that likes to guess the puzzle before I even give any clues, so I'm just going to pause for a few seconds. We're going to start the puzzle. Any guesses, Tobiah? I suspect he probably got it wrong. Okay, this puzzle has 10 clues. First clue, and I think it just maybe quietly say, don't be shouting these out today. So first clue is I'm a politician. I was born in Chicago in 1947, and clearly it's not Barack Obama because some people question where he was born at all. I attended Wellesley College. I became a governor's wife. Though not a Londoner, I have a bit to do with Chelsea. I've been a first lady. I was elected senator of New York. I served my one-time rival as Secretary of State. Trevor Strobel idolizes me. And I will be president in 2016. All right, if you haven't guessed it yet, you know it. Yes, Hillary Clinton. All right, then I have a joke for the day. And the joke, oops, got to turn the page. The joke is this. A woman took her husband to the doctor for a checkup. After the exam, the doctor pulled the wife aside and said, I'm afraid your husband is ill. The only way to help him is to feed him 3 healthy, homemade meals a day, keep your house spotlessly clean, and forbid him to do any work around the house. On the way home, the husband asked what the doctor had said to her. Oh, she replied, he said, you're going to die. All right, little pause for laughter. All right, maybe that's enough. Okay, let's get this lesson going here and let's take care of it. So we're going to solve separable differential equations. And what is a separable differential equation? Well, it's going to be a differential equation. And you're going to be able to separate the variables, get the y's with the dy, the x's with the dx. And you're going to be able to separate it using multiplication or division. And this is the only kind of differential equation we'll deal with all year. So, once you get the hang of it, you'll realize, hey, this isn't too bad. So let's do this first one. We have a differential equation. Look, there's a derivative in it. Always the first step would be multiply by dx. So I've got x squared, y squared, dx. And then I notice the y's on the wrong side. I can only use multiplication or division. So I'll use division. Multiplication wouldn't work so well. I get 1 over y squared dy equals x squared dx. Okay, so we can separate it. On the next slide, don't worry, we will solve these differential equations, but just to show you the separation part. Next problem here, let's multiply by dx. So I get dy equals y over x dx. And again, how do I separate? I divide by y. So 1 over y dy equals 1 over x dx. So I've separated it. And this last one looks a little trickier, and on first glance you might think, oh, I can't separate that. But I can. So I'm going to multiply by dx. I get dy equals the cosine of x. And I believe this is a homework question. Cosine of x, e to the y plus sine of x dx. Now I've got to get the y over with the dy, but I can't take the x's with it because the x's have to stay with the dx side. So on the right side I rewrite this. I've got the cosine of x. And I use my rule for exponents. This is e to the y times e to the sine of x dx. And now I can bring this to the other side. I'll divide by e to the y. So I can write it as 1 over e to the y dy equals cosine of x e to the sine of x dx. And then just so you don't get fooled, 1 over e to the y is really just e to the negative y dy. So that's how you separate a differential equation. And that third one's a nice example because something that might not appear to be separable, with a little bit of cleverness, it turns out it really is separable. All right, now let's actually solve two of these differential equations. And again, what's our method going to be to solve a separable differential equation? Separate the variables and then take the integral. All right, so let's try this. Actually, this is a little different than our example, the ones we just did. Let's try this. And they give you this condition here. Just hang on to this. At the very end, when we get our plus c, we'll use that y equals 2, x equals 1 to figure out our c. Okay, let's separate, multiply by dx. So dy equals x over y dx. Oh, shoot, the y's on the wrong side. And since it's on the bottom of the fraction, what do? You multiply. So I get y dy equals x dx. Then how do you solve a differential equation? You take the integral. Scoot that up a little bit. Let's go a little higher. All right, so take the integral of both sides. And the integral of y is y squared over 2. And over here, the integral of x is x squared over 2. And since we've taken an integral, don't forget there really should be a plus c. And there's only a need to put it on one side, so I'll put it on that side. I'll go plus c. Now I'll multiply through. You want to solve this for y. I don't like the fact that there's 2 on the bottom. So multiply both sides by 2. And I'll get y squared equals x squared. And you could call that 2c, but I haven't figured out c yet. So let's just call it c, understanding it's a slightly different c than the c above it. Slightly different meaning twice as big. Okay, let's figure out our c. So you come back up to the beginning of the problem, and we know y is 2 when x is 1. So y is 2 when x is 1. We sub those in. Y equals 2. And x equals 1. And very easily we can figure out our c here. 4 equals 1 plus c. So 3 equals c. So come back now to our equation here. And we can say, look, y squared equals x squared. And our c is 3, so plus 3. All right, we're not quite done. We don't want y squared. We want y. So how do you get rid of the square? You take the square root. And so I'll write this right below it. So y equals the square root of x squared plus 3. But guys, when you take a square root, you have to think, wait, a square root, is that plus or is that minus? So again, you come back to this initial condition and say, well, wait, when x is 1, y is a positive 2. Look, that's just a 2. So I will take the positive square root, because when I put a 1 in for x, I get 1 plus 3 is 4, and the square root of 4 is 2. So I take the positive square root because of this initial condition. Had that been y is negative 2, I would have taken the negative square root. But I'll take the positive square root because of my initial condition, and I have solved that differential equation. Y equals the square root of x squared plus 3. All right, we have just one more problem to go. If someone could just check in the front row, is Lucas still with us here? All right, very good. And let's go on to the second and final problem. All right, we have dy dx equals cosine of x e to the y plus sine of x. This is that one we set up before. It doesn't hurt to work through it again one more time. So I'll just for hopefully clarification or just to cement these ideas. So I'll multiply by dx. I get cosine of x e to the y plus sine of x dx. On the right side, I'll write that cosine of x e to the y e to the sine of x dx. I'll bring the y over to the left side, so it's 1 over e to the y equals cosine of x e to the sine of x dx. So this is a nice challenging problem for you guys. The first two were the first one was a nice little warm-up problem, and this will be a bit more of a challenge. Okay, let's take that 1 over e to the y, let's write that as e to the negative y equals cosine of x e to the sine of x dx. Let's take the integral of both sides. The integral of e to the negative y is negative e to the negative y. Okay, on the right side, how do we do this integral? Well, let's do a u to u substitution. And let's let u equal sine of x. And the derivative sign is cosine of x dx. And how does that look to you? Hopefully that looks really good. It's because we now have e to the u, and look at that, cosine of x dx, cosine of x dx, that's just du. Nice. What is the integral of e to the u? It is e to the u. So this equals e to the u. But wait a minute, what was u? U was the sine of x. Let's keep scrolling down and following this. So I've got negative e to the negative y equals e to the sine of x, and I feel like I'm forgetting something. You've got it. Plus c. All right, so I've got that. Oh, and back up above when people are suggesting that u equals x. No, that is not correct. U will never be x. Okay, let's solve this for y. And again, up here, notice there was no initial condition this time. So we don't have to figure out the c. The c is just going to work through the problem. They didn't give us any information like y equals 2 and x equals 4 or something like that. So we've just got this problem as is. All right, let's get rid of the negative sign. I'll multiply by negative 1. So e to the negative y is negative e to the sine of x. And again, the constant hasn't been declared yet, so we can just keep it as a plus c. All right. How do I get rid of that e? I'll take the log of both sides. And the log of e gives me negative y. And guys, it's the log of the whole thing. Logarithms do not distribute. So I'm going to write the c, well, I'm going to write the c first, just for a little clarification, minus e to the sine of x. And just to be careful with that, oops, try that again. I'm going to put that in an absolute value, just so we're careful with that. So that would be the natural log of the absolute value, and I'm going to put the c first, minus e to the sine of x. No big deal, but just it looks, I don't know, to me it looks a little better that way, instead of that negative sign. And then what does y equal? I got to get rid of the negative, and there's a couple ways you can do that. One way is multiply by negative 1, so y equals negative natural log of the absolute value of c minus e to the sine of x. And it would not be unusual to use log properties and bring that negative, which is really like a negative 1, and bring that up in the exponent. And so I've got y equals the natural log of the absolute value. This is a negative 1 power. That means a reciprocal, 1 over c minus e to the sine of x. And that's about as tricky as a problem as you could make with these separable differential equations. Okay? So again, this is chapter 6. It's section 4. There'll be homework problems that look just like this. And the idea is whenever they give you a differential equation, you want to multiply by dx, get your y's with your dy, get your x's with your dx, and then you take the integral. And there's 3 nice kind of starter problems here. We didn't finish them by taking the integral, but it gives the idea of it. And if you look at the homework, you're going to find more problems just like that. And like I say, I'm pretty sure, if I remember correctly, that actually is a homework problem. So we will stop here. That is to get you started. You can now start your homework. It's chapter 6, section 4. Give that a start, and you should be able to make a lot of good progress on it. Some of those exponential word problems are kind of funny looking with the half-life and whatever. But you should be able to make good progress on those. And in these separable differential equations, same thing. You should be able to make some really nice progress on that. So that is it. Guys, enjoy the rest of the day, and I will see you tomorrow.